All right, two more examples to go. These ones are a little bit different because they have to do with objects being thrown up in the air or falling. Okay, so in the first one, you throw a ball upward and it passes by a window 3 meters above the ground. The window is 2 meters tall, and it takes 0.4 seconds to go by the window. From the bottom of the window to the top, what initial velocity did you give the ball? So when I do these ones, I do my givens up and down this time because the ball or whatever the object is going up and down. Okay, so there's the ground. We'll make this below the window. And we'll make this section the window. Okay, so it says you throw a ball upward and it passes a window. So we don't know what the VI is. So that's a question mark. It passes by a window 3 meters above the ground. So the delta D of this section is 3 meters. And it's 3 meters up. We also know the acceleration is 9.81 meters per second squared down. It says the window is 2 meters tall, so that's delta D of this section. 2 meters, also up. And it takes 0.4 seconds to go by it. Delta T is 0.4 seconds. Now you cannot assume the VF is 0. It doesn't say it stops when it gets to the top of the window. It just says like you're timing it as it goes by, but it can keep going up. So we don't know the VF. We do know that A equals 9.81 meters per second squared down though. Okay, so that's all our givens, and it wants to know what's our initial velocity. Well, the key to this question is realizing what's common in the two sections. And what's common is that as this ball goes up, when it reaches the window and begins to leave the section below the window, it has some VF. We don't know it, but we know it has some VF. And then as it crosses this imaginary line that we've made, it has some VI. We also don't know it, but hopefully we know that they're the same. So the VF that it's leaving below the window with is the VI that it's starting the window with. Why is that important? Because now if you look at this upper section, we only have one unknown, which means we can find our VI. And once we have our VI, then in this lower section, we'll only have one unknown because that VI becomes our VF below the window, and then we can find our other VI. So start with the window. So first, window. And feel free if you want to turn this off here, do it, and then turn it back on to see if you got it right. Okay, starting with the window, it would be delta D is equal to VI delta T, 1/2 A delta T squared. And you need to rearrange for VI. So you need to subtract the 1/2 A delta T squared. And that will give you VI delta T, and then divide by delta T. So VI will equal delta D minus 1/2 A delta T squared over delta T. And now we're going to fill in our numbers and watch your ups and downs. So the 2 meters is up, it's positive. Minus 1/2, gravity is down, it's negative. 9.81 meters per second squared times 2 seconds, no, sorry, not 2 seconds, 0.4 seconds squared divided by 0.4 seconds. Assuming you remember to square your time, assuming you remember to divide by everything by 0.4, you should get 6.962 meters per second. Okay, so that becomes our VF of this section. And so now we can get our VI, so second, we would do VF squared is equal to VI squared plus 2A delta D, solving for VI, so subtract the 2A delta D. Fill in your numbers. So VI squared equals, VF is what you just found, 6.962 meters per second, and that'll be squared, minus 2 times negative 9.81 meters per second squared, and by the way, this was going up, times delta D, which was 3 meters going up. Remember, that's VI squared. It'll be 107 point something, I think, 0.3294, etc., meters per second, meters squared per second squared. Take the square root, 10.36 meters per second. You want the positive, it's up. Okay? So that's if you're throwing it up past something. The last example is you're dropping it. So it's a chemistry textbook that's being dropped off the roof of a building and reaches the lab window 3 meters below. So again, I would do my givens up and down. This time it's above the window because it's being dropped from the roof and the window. So it says it's being dropped, which means VI is 0. Reaches a lab window 3 meters below, so the delta D above the window is 3 meters down. And of course the A is 9.81 meters per second squared down. If it takes 0.2 seconds to pass the lab window, so now we're down here, delta T of this part is 0.2 seconds. A, of course, of this part is 9.81 meters per second squared. What is the height of the window? You're looking for delta D of this section. Okay, what again connects the two parts? The VF of above the window, because it's going down this time, will be equal to the VI of the window. Again, you want to start with the part that only has one unknown. So start with above the window. So above. You have VI, delta D, and A, and you want VF, so use VF squared is equal to VI squared plus 2A delta D. The VI is 0. So VF squared is equal to 2. Everything's going down this time, so you actually don't need a positive and negative. You can call down positive. So 9.81 meters per second squared times 3 meters. And remember that's VF squared, so you have to take the square root, and you get 7.672 meters per second squared, and that's going down. Okay, that becomes your VI of this section. This section you have an A, a delta T, and a delta D, or you want a delta D. So use delta D is equal to VI delta T 1/2 A delta T squared. And this that we just found is our VI. Okay, you're looking for delta D, so you don't even need to rearrange. So 7.672 meters per second times 0.2 seconds plus 1/2, 9.81 meters per second squared times 0.2 seconds squared. When you do this, first term is 1.5344 meters, and the second term is 0.1962 meters. You should get, for this answer, if you did it all in one step in your calculator, 1.7306. And I'm fine if you did it all in one step. I was just giving you the two separate answers in case you screwed it up typing it in. Okay, so that's the last example. So now your homework questions will be on that harder sheet on the back side, okay?